welcome to Classroom V2 once again. Today we'll be doing another question on moments. This question is slightly different from the last question. We have 3 forces, but we'll be applying the same principle. On the left we have 10 newtons, and on the right we have 2 forces this time, 10 newtons and 2 newtons. The 10 newton is y meters away, or the 2 newtons is 5 meters away from the fulcrum. On the left hand side, the 10 newtons is 4 meters away from the fulcrum. Like previous question, the system is in equilibrium, so the left hand side will equal the right hand side when we proceed with this question. So we proceed with this question by splitting the diagram up to the left hand side and the right hand side. After this, we proceed to draw the table to find out the moments on both the left hand side and the right hand side. For the left hand side, we only have one downward force, and it's 4 meters away from the fulcrum at 10 newtons. So it will give us 40 newtons meter. This time we have actually 2 forces, so we have to take note. The first force we have is 2 newton and 5 meters away, which will give us 10 newton meter. Okay, so let's just indicate the direction of force for both equation first, and we proceed to the next one. The next one we have is 10 newton. The distance is what we are going to find, so we list it as y meters, which will give us the equation of 10y Newton meter downward as well. We'll take downwards as positive and upwards as negative in the equation. So if now we proceed to form the formula, left hand side equal to right hand side, since the system is in equilibrium. The left hand side we have 40 Newton meters, while the right hand side is 10 Newton meter plus the 10y Newton meter that we have found on top. If the 10y Newton meter is actually upward force, we will have to use negative, since we already declare the upward to be negative and downwards to be positive. The following steps are just basic algebra that we have learned over the years, and we try to solve finding y, which will give us y equal to 30 over 10, and that will give us to 3. So y is actually 3 meters, and the 10 Newton meter force is actually 3 meters away. This will keep the system in equilibrium. So just take note that the upward force and the downward force we have to take into consideration when there are additional forces acting on the fulcrum of different directions. Okay, thank you.